Step 1. Begin by calculating the Lane Normalization Factor. Blots are inherently variable, non-uniform, and have inconsistencies. In order to compare blots efficiently, each blot should be normalized. Normalization uses an internal loading control to correct for unavoidable sample-to-sample and lane-to-lane variations and provides proof of equal protein loading per lane. More information on how to select a normalization strategy can be found in the normalization course here at Lambda U. Now, let's see how to calculate the Lane Normalization Factor. Lane Normalization Factor is calculated for each blot and cannot be reused between blots. It is calculated based only on the signal intensity of the loading control. Lane Normalization Factor equals the signal intensity of the target band divided by the highest signal intensity of a loading control band in a given blot. Again, we're looking at the signal intensities of the loading control alone and not the target bands. After you have determined the Lane Normalization Factor, create an analysis workbook with the raw signal values for your loading control. This will be used to calculate normalized signal values. Identify the raw signal for loading controls using the imager software. Notice the raw signal values, which tells us that approximately the same amount of loading control protein was loaded per lane. Next, identify the highest value of loading control in the entire blot. In this example, the highest value is 1000, present in lane 3. To calculate Lane Normalization Factor, divide signal intensities of each loading control lane by 1000. This step of dividing the signal values by the highest signal value is critical to calculate normalized signal values, which in turn will generate accurate and reproducible Western blot data.